Hi, and welcome to this week's episode of Carrier Wrap. I'm Kelly Hill, RCR Wireless News Editor for Test and Measurement. On this week's show, we'll be talking with the Wi-Fi Alliance about its new certification program for Wi-Fi coverage within the home, and with some of the New York University wireless researchers who recently got a $2.3 million award to develop a platform for exploring millimeter wave technologies for public safety. All of that after this. So I'm here with Kevin Robinson, VP of Marketing for Wi-Fi Alliance. How you doing, Kevin?
I'm doing great, Kelly.
Good. So you guys have a new program, Wi-Fi Certified Home Design. So tell us a little bit about what you guys are doing with that.
Absolutely. So Wi-Fi Certified Home Design is a new program from Wi-Fi Alliance that really elevates the connectivity experience in new home construction. So if somebody goes out and buys a home that has gone through this home design program, the user can feel very confident that they're going to have a Wi-Fi network that meets their connectivity needs, performance needs, capacity needs. So, in a way, it's almost taking many of the lessons the industry has learned in deploying high-performance networks in the enterprise and transferring that over to new home construction. And in the end, the user is going to get a great experience from one of these homes.
And so this works, but so they submit blueprints and those go through, some process where, folks look at, what propagation characteristics or like what building materials are used. Can you tell us a little bit about the details of, of how a home goes through this process?
Yeah, absolutely. So this is new home construction. So the builder really is starting with kind of a blank sheet of paper, and they have their blueprints of what the floor plan looks like. They know the materials that are being used. And then they're using very typical practices in how a network planning could happen. So taking into account things like you said, access point location, RF propagation through the home and how that interacts with the building materials, looking at the device density that you might have in the home. So for example, making sure that they're building these homes and planning a network that's future-proofed, right? That it's able to handle 35 or more devices on a single AP without even coming close to using up the total utilization of that airtime. So as well as looking at latency, making sure that you have low latency in the neighborhood of 10 milliseconds within the home. So again, looking at a lot of important characteristics that all kind of go into delivering that good experience to the point where the technology, the connectivity really fades into the background, and users are more focused on living their lives and accomplishing the things that they want to on top of that technology.
And what are there any requirements in terms of, what type of equipment, whether it's AC, whether it's legacy, whether it's, running on 2.4 or 5 gigahertz?
Yeah, absolutely. So one of these home designs, they all support Wi-Fi certified AC. So it's using the current version of Wi-Fi. Of course, the access points are certified, which gives you that interoperability expectation. So obviously, the home builder is going to have a set of kind of curated clients. Maybe it's a Ring doorbell or maybe Lutron light switches or something like that. But the homeowners also, I don't know if you've bought a home and never gotten the mailer with about 57 coupons from Home Depot or Lowe's, right? So the expectation is the user is also going to go out and buy new clients and bring those into the home. And by ensuring that the network is Wi-Fi certified, the home builder can feel confident that the users can have a good experience with those devices as well.
Okay. What about as far as, so obviously this feeds, I think, very nicely into the smart home trend that we're seeing. There's a lot of additional demands on Wi-Fi, but I think it also says something about how people value Wi-Fi and how much they depend on it. Thoughts on sort of, how this new program, is reflective of the demand and the need that people feel for Wi-Fi in the home.
Absolutely. I think that first and foremost, it highlights that connectivity in the home is absolutely critical. It's expected. I mean, people, quite honestly, even look at CTIA recently did a study, and they were looking at what people consider when they go buy a new home. And they were looking at wireless from the cellular perspective, but people actually related wireless connectivity above good schools. Okay, so that kind of tells, now it might be a little bit scary, but it tells you something, that connectivity is absolutely central to our lives today. And within the home is where that's probably most important. And with this program, I think what it highlights is that builders view Wi-Fi connectivity as important as when they install lighting fixtures or HVAC or any of the other things that you would just honestly expect to be in your home today. And it also establishes that Wi-Fi really is the de facto connectivity technology in the home. There will be other technologies, but Wi-Fi really is the foundational technology for delivering wireless connectivity within the home.
Okay. And you guys already have one builder who's participating, right? And there are existing homes that have plans that have been certified, yes?
Absolutely. So Lennar Homes has already certified home designs under this program. They've announced in a recent press release that they'll be talking about additional communities that will have those homes available coming up very soon. So they're very involved. And I think, just to get back to your last question, something specifically about Lennar was they actually did a survey of previous customers. So people who have come in, they've purchased homes from Lennar, or maybe they've come into a model home and they've are interested in purchasing a home. And about 64% of those people said that they would actually be willing to pay more for a home that has integrated Wi-Fi connectivity. That's kind of a turnkey experience when they walk in. So again, really illustrates the people's affinity for Wi-Fi and the power of a very high performance network in the home.
Okay. Great. Well, that's Wi-Fi certified home design. Thanks so much, Kevin. Appreciate the perspective today. All right. So our next conversation is with a trio of researchers from New York University's Tandon School of Engineering. NYU received $2.3 million in funding from the National Institute of Standards and Technology. And that was part of $38.5 million that NIST gave out to support innovation and research in public safety communications. So awards were announced last week, and 33 projects were funded, projects ranging from augmented reality helmets to real-time video analytics. You can read more about that on our crwireless.com. So the largest single grant was to New York University for an end-to-end research platform to explore the use of millimeter wave in public safety communications. I caught up with some of the recipients at NYU to hear more about what they're going to be doing. Here's an interview. This is Kelly Hill, editor for Test and Measurement at RCR Wireless News, and I'm here today to talk to some folks at NYU's Tandon School of Engineering. First of all, we have Sandeep Rangan, who is in charge of the NIST PSCR project that was just recently awarded. He also directs NYU Wireless and is an associate professor of electrical and computer engineering at NYU Tandon. We have Marco Mazzavilla, an NYU Wireless research scientist, and he's also program director for the NIST project. And then we also have postdoc Aditya Dhananjay at NYU Tandon. And so, gentlemen, let's get started with a little bit of a discussion. So you folks were part of the $2.3 million award over 3 years from NIST's Public Safety Communications Research Division. Tell us a little bit about what you're going to be doing with that and what you're going to be exploring.
Thanks a lot, Kelly. So we're very appreciative of this award from NIST. The program, there's been a lot of interest in using cellular technology for the purpose of public safety. That's what the FirstNet program was originally about. What our proposal was to look at 5th generation or next generation cellular systems, in particular looking at technologies above 6 gigahertz, including the millimeter wave spectrum. And those can offer much greater data rates, much lower latency, and then potentially offer new types of applications for first responders in these emergency scenarios.
Okay, great. And there are some partnerships, I think, that are part of this as well. Marco, maybe you can tell us a little bit about those. I think the Austin Fire Department is one, and I think there's a couple of others.
And yes, so we have 2 partners. One is University of Padua, and one is the Austin Fire Department. So University of Padua we've been collaborating with them for the last few years on designing all our research platform for millimeter wave for cellular networks. which is the reason why we decided to have them on board for this new exploration of public safety scenarios with millimeter wave communications. And on the other hand, we have the Austin Fire Department as a partner, which I personally found because I saw that the status of their technology and in their offices they have drones and robots, which apply perfectly to our idea of bringing millimeter wave to these new scenarios with new devices. And what we expect to gain from this collaboration is their personal experience, their personal insights on what is needed in such scenarios, in such emergency scenarios, which is completely different with respect to mobile cellular networks. So the combination of what we know in telecommunications and in cellular combined with their own experience in these emergency scenarios, I think will be the key for us to understand if millimeter wave is feasible for public safety communication. In fact, it's a research platform, what we're working on here, and we're happy to gain insights and test. So that's our goal.
Okay. Speaking of test, I see that you guys have some equipment there, obviously. So can you tell us a little bit about what we're looking at?
Sure, I could start. This in front of me is a phased array, which is the basic antenna system that you need to transmit these millimeter waves in a steerable directional manner. This actually came from a generous donation or partnership with one of our affiliate members. In addition to the two partners actually that you mentioned, NYU Wireless works closely with a large number of affiliate member companies, and their help will also be leveraged for the program. This one came through National Instruments and Cybeam, which fabricated the 60 gigahertz array. And we'll be using this for a lot of the testing, both in the channel sounding part of this, as well as the software-defined radio part. And then
then the box over here is a software-defined radio platform from National Instruments. So you can think of a software-defined radio box as having different pieces that you can mix and match and put them together, quite like Legos, in order to build a radio that you would like. And once you test and prototype and make sure that everything is fine, whatever sits inside this big, heavy, expensive box would hopefully be fabricated onto a little chip that will go into the devices that is used by the first responders. So of course, while this project does not involve the fabrication of any chip, the software-defined radio platform is going to be used for a lot of the prototyping and testing work that we're going to be doing here.
Okay. And so speaking of some of the further steps down there, what do you see as some of the primary challenges and opportunities as well for the use of millimeter wave for public safety? This is, we were talking about 60 gigahertz. That's some fairly tricky spectrum to work with.
Yeah, so you are right that the propagation characteristics at 60 gigahertz is quite challenging from a public safety standpoint. But the reality of the matter is that in all likelihood, frequencies lower than 60 gig might be used for the public safety applications. And so the propagation characteristics in general, as you move lower down the frequencies, becomes better. So by testing and by building and prototyping and testing at 60 gig, and we can be reasonably sure that if it works at 60 gig, the same techniques will be applicable for the frequencies below 60 gig. And of course, the whole point of the software-defined radio platform is that you can pull out the 60 gig module and replace it with a 28 gig module or module at whatever frequency of your choice, and you can test and see what the performance of the systems are going to be.
Yeah. That being said, though, even at 28 or the other millimeter, there are going to be a lot of challenges for this. And that's why we need to be trying to study this grant, the feasibility of the biggest challenge is that the millimeter wave signals are blocked by a lot of materials that conventional frequencies are not blocked. So they'll have definitely reduced range in certain circumstances. And we're going to be trying to understand that as part of the grant. The other aspect, which I think I alluded to before, is that you have to transmit in very narrow beams. So there's a whole issue there about searching, finding beams, and tracking, which presents other challenges, particularly in mobile environments where, like on a drone or something like this. So these are all things that we'll have to assess the feasibility. So millimeter wave broadly has a lot of potential because of the higher data rates. Marco can maybe talk a little about some of the applications of those data rates, but then they do have challenges, and that's why this, we're looking at to see how these work out.
So is this largely a feasibility research, or are you guys going to be exploring specific use cases? Can you tell me a little bit more about the details of what you're going to be exploring with this funding?
It's kind of both. I think what we're really trying to do is actually, because it's very early stage for looking, it's an early stage in millimeter wave in general, even in the cellular environment. This is very new for public safety. The goal was really to provide a research platform or the tools that people could do this kind of foundational research. So feasibility, channel modeling, and these basic components are part of this, but also simulation platforms. And those can be used by application developers to understand scenarios. And we're also really trying to, a lot of the early stage of any type of research is more the requirements and use case scenarios. And that's where it's so critical, as Marco was pointing out, with working with the Austin Fire Department. So people in our community can understand what's really needed and what's not needed. And then those would also be part of the study. So requirements, use cases, as well as channel models and things like this, and all the fundamental tools that will be used to evaluate. So we hope that other research institutions and fire departments and others build on what we develop here to understand the public safety use case more.
And will this be, is this work that you expect to be directly applicable to FirstNet? Does it also have, the potential of being used in, in other countries around the globe?
Yeah, I mean, just one thing though, FirstNet specifically was a very specific band at 700 megahertz. And so obviously the millimeter wave would require new band. It will still be up, we'll still have the spectrum, even for the traditional cellular, is just being worked out now. If the FCC decides at some later point to allocate, they may decide based on this and other research to allocate separate bands, or potentially to share those bands, which is another aspect we've been looking at in terms of spectrum sharing in these millimeter wave bands. How the spectrum allocation will work would be different. But the principle of FirstNet, of the idea of using cellular technology for first responders, is still there, but it would of course have to be reallocated to a different band.
Okay. Great. Any final thoughts from the three of you on, on what you're hoping to accomplish or what you're excited about? Marco?
So like I said before, for me also a personal thing is the idea of utilizing all the wireless expertise that I have accumulated over the last 5 to 6 years and apply them to a new context where we're truly talking about helping people to save human lives is very exciting. It's a new thing, and we're very happy to think that we might make an impact here. Again, we're not saying that we will provide a solution. We are working on providing the platform to understand and help, ultimately help agencies like FirstNet or whoever worldwide to see if this is a potential way to go. And indeed, the idea of having this as a solution would be fantastic for us to think that we helped moving the first steps towards that direction. And also, like Sandeep mentioned, we're talking about drones, we're talking about robots, we're talking about cutting-edge technologies, and associating communication paradigms to these new technologies is also something that we're very keen on working for the last year or so.
Well, and I think it's interesting because, a lot of people I think in the industry are talking about millimeter wave and 5G. This is one of the first instances, though, where I think I've really heard people talk about public safety in that context. And, I think in a lot of ways, because public safety is very concerned about, reliability and whatnot, as well as cost, their systems, I think, in some ways have tended to lag behind cellular. So I think in some ways it's nice to see this part of the discussion happening before 5G happens.
I very much agree. Also, I mean, actually, it has been cited, at least in the IMT made a big study of use cases for 5G, and it is listed there. But I believe that so people have thought about the idea, but it's really not explored. Gone too much further, and this will really push that.
Exactly.
Well, hopefully you guys will help push that conversation.
Yeah, I'm really looking forward to it.
All right. Well, thank you all so much for your time today. I appreciate it very much. And all of us coming to us from the NYU Tandon School of Engineering. Thank you.
Thank you, Kelly.
Thank you, Kelly.
Thank you.